Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you missed any or all of the event, you will be able to access it later on demand. Excuse me. We will be sending out an email following today's webinar that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please do not wait. Don't hesitate. Just use your GoToWebinar control panel and submit your questions. And we'll take a few minutes near the end of today's webinar and go through them. And finally, we are doing a drawing at the end of today's webinar for 3 $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 3 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is DevSecOps, closing the loop from detection to remediation. Our speaker today is no stranger to the DevOps.com webinars, Shiri Ivtsan, who is Senior Product Manager at WhiteSource. Hi, Shiri, how are you?
Hi, Charlene, I'm great. How are you?
I'm doing great, thanks. Great to have you back with us.
Yeah, definitely.
All
Thank
right.
you for the intro.
You're welcome. I'm going to put myself on mute and let you get right to it.
Thanks. Okay, so thank you for joining the webinar once again. Today we're talking about closing the loop from detection to remediation. So if you are familiar at all with security vulnerabilities and specifically open source security vulnerabilities, you probably know that the detection of the vulnerabilities is probably the easiest part. It's really easy to know which vulnerabilities you have in your application. If you're using a dedicated tool or if you're using an open source tool to do that, detection of vulnerabilities is pretty easy. But the hard thing is to close the loop and actually remediate those vulnerabilities. So we'll try and solve this very big challenge by giving you some basic steps that hopefully you can implement in your organization even starting tomorrow. But first of all, let's look at the DevSecOps world. So if DevOps is all about the automation and collaboration of development and operation processes, the DevSecOps world goes a step further. So it's calling the adoption of security measures into the development process. And we sort of see this in the visual that you can see. So we have the planning, the coding, the building, testing, and all those steps. But then we have security, which is sort of wrapping everything. So security is not a specific step. It's not like a testing that you do once and then you release the software. It's basically something that you have to do continuously. So if we're speaking about DevSecOps, of course, it involves the CI/CD pipeline and bridging the traditional gap between security and development team. And actually, it is quite a big gap. I mean, the collaboration between dev and ops is a more natural one. They come from the same world. But if we look at development and the security teams, they always had sort of opposite objectives. So if we have development who's geared towards agile development, fast releases, thinking all the time about the next feature to come or implementing the next task, deploying the next version. We have the security teams on the other end that are sort of not the opposite, but a contradicting goal. So they want everything to be secure, they want to have auditing in place, and usually or sometimes they're being seen as sort of a bottleneck within the organization and specifically for developers. So bridging the gap and looking into DevSecOps is quite a big challenge. So even before starting to speak about closing the loop between between detection and remediation, we need to sort of take a deeper look at the DevSecOps world and what it actually means. So DevSecOps means integrating DevOps and security culture. So not specifically integrating the teams together, but more of giving the awareness and integrating the security aspects and integrating those practices with the DevOps processes. So in the previous slide, we saw the different processes that we have within the pipeline, like coding and testing and building and monitoring. And the idea within DevSecOps is sort of to look at each one of those processes and to think about how can we integrate the security part in it. And it also includes, of course, using the agile methodologies to deliver small and secure pieces of code in frequent releases. So even if you don't have security integrate throughout all the pipeline, the idea is to start with something. So if you have one piece of code, you need to make sure that this is secure and has frequent releases. And we will speak a little more about the idea of why we need to release so frequently. Why is it that important? And it's not only important because of the business aspect. I mean, because my customers want frequent releases, it's also important on the security aspect. The next part is, of course, to automate. So the DevOps world is all about automating processes, and honestly, we cannot do anything without automating. So if the security world, let's say 3 to 4 to 5 years ago maybe, was considered to be something very slow, what the DevSecOps idea is all about is changing that. So automating and delivering very fast and small pieces of code and of processes, of course. And we always mention that the best response to the bottleneck is to have a modern continuous security pipeline. And this is a very important note. So let's look at the common ways of handling vulnerabilities. And by the way, we see this almost in every company that we go to, even when I speak to customers. And usually we think, no, this is, most people already automate the security part. So in fact, most of the users that we speak to still have this challenge of even automating and actually remediating the vulnerabilities. So let's take a look at the common way of how people actually handle the security issues. So let's say you have a very large product with a lot of lines of code. Usually the security teams will analyze and prioritize the vulnerabilities. Okay, so one day they basically say, okay, we need to take care of the open source vulnerabilities. And then they go through the code, they detect the vulnerabilities either manually or using some automated tools. And now they have this list of hundreds of vulnerabilities and they actually need to do something with them. So first of all, they would prioritize. And one of the questions that we asked our users is, based on what do you prioritize the vulnerabilities? And we got many responses. So some of them were we prioritize based on the severity. Each vulnerability actually has a severity. It can be high, medium, or low. So some of them prioritize based on the severity. Some of them would prioritize based on how easy it is to fix the vulnerabilities. Some of them said that they would prioritize based on the date when the vulnerability was first disclosed, which probably means that if it's an old one, it can be exploited easily. So we got all kinds of answers, and not all of them actually have to do with the business impact, which is probably the most important aspect. Whether or not this vulnerability has any impact on my business, right? So this is a very important question. So let's say that they prioritize the vulnerabilities based on any of the answers that we got. Then what they would do is, of course, they cannot handle the vulnerabilities by themselves. Usually, the way to handle a security vulnerability, if we're talking about the open source world, the way to actually handle it would be to upgrade a specific version, the version of the open source library that you're using. So the security teams cannot do that by themselves. They actually need the development team and sometimes also the QA team to upgrade the version and then to test that everything is still functioning and everything is still okay. So they will send emails or they will open a ticket or an issue in a ticket management system to the relevant developer. And they would say, okay, you need to upgrade this component. Maybe it's one component, maybe it's a list of components. Then the developer will actually have to evaluate it. So, of course, upgrading a version is something that has a lot of impact. Either the new version can break the backward compatibility, meaning they will have bugs or issues with the actual functionality of the code. Or maybe it has other aspects of failing tests or failing builds. So they really need to go and for each one of those libraries or components, actually analyze the impact on their existing version. As we spoke, an average product or an average software will have hundreds to thousands of such vulnerabilities. And as we said, this is not the first priority of the developers. So they would get this email, and then closing the loop on the resolution is very hard. It's very hard for me as a security person to understand whether or not the developer actually fixed the issue. Which issue did they fix? Which issue is maybe doesn't need a fix, or maybe it's too complicated to fix it and they cannot do it. So everything goes through either emails or tickets, and it's really hard to understand which vulnerabilities have been remediated. So this is one of the greatest challenges. Now, let's talk about how we try to solve that. And we try to solve that by actually shifting the mindset. So we try to shift left, and shift left basically means to go left in the life cycle, more to the coding and to the building part, other than looking at the vulnerabilities after they are in production, like in the previous method that we just showed. And the idea is to close the loop by giving more and more awareness and more power to the developer. So the first point is actually to build guardrails and don't be gatekeepers. So in the previous examples, the security teams are more like gatekeepers. They have a list of all the vulnerabilities, and probably if a new developer or an existing developer wants to add a new open source component, they need to consult them. They need to get their approval. So they are really bottleneck. This creates a very big bottleneck, and they become gatekeepers. And the idea here is to build the right processes and to avoid bottlenecks in the process. The main idea is that if the process slows you down, let's say the process of handling vulnerabilities or the process of approving new open source components, the process probably needs to be changed. The third point is very important. It's all about awareness, and it's about making security everyone's responsibility. So security is no longer the responsibility only of the security team as it was before. We want to have regular discussions about the application security throughout the development process. So this really needs to be something that is part of the process, part of the day-to-day work, both in terms of how we treat security issues, This is not a specific person's problem. This is everyone's problem, as we all have the same goal of delivering software without security vulnerabilities. But it also means having the right processes in place. So if we look at this from a business perspective, I think the business benefits of DevSecOps are quite maybe clear. So we always look at this as like the triangle of cost, time, and quality. I mean, if we add more time, we will have more quality. If we reduce the quality, probably it will be cheaper and take less time. And of course, if we reduce the cost, it will take more time and be less qualified. So these are like the three pillars. And then when we look at DevSecOps, basically we can help with all the three. So first of all, cost reduction, right? If we detect vulnerabilities as early as we can in the life cycle, this actually reduces the cost. So think about a situation where as a developer, didn't even start developing with with a component that has security vulnerabilities. Instead, I chose to use a component that doesn't have any security vulnerabilities because I was looking and I was taking this into account as I started to code. So in the beginning, I saved a lot of money by not needing to redo any of the work. Then we, of course, have speed of delivery. If we don't have any bottlenecks in the process, like in the process that we spoke about before, where the security team have to validate and approve each and every one of the components, we actually get to a very fast delivery, which is, of course, our intention. Then, of course, it's secure by design. So there's no need to go back after the software was already released to the market and think whether or not this is secure and whether or not they have security vulnerabilities. So the quality is a lot better. And then, of course, it facilitates an open discussion. So not only everyone is aware of the security part, there is no more finger pointing at a specific persona in the organization as per like it's his fault or her fault. It's now everyone's responsibility, which is probably the most important thing. Then we also have some operational benefits of DevSecOps. So first of all, the versions are up to date. And this is a very important point. Why are the versions up to date? So we spoke about it before, but maybe we didn't go into it deeper enough. So the idea is that almost every security vulnerability that is being disclosed today and published actually has a fix in a newer version of the same open source component. So around, I think it's 90 to 95% actually have a newer version that fixes the specific vulnerability. So this means that if you keep your versions up to date, this will be like 95% of the solution to the vulnerabilities issue. So if you have CI/CD in place and you have automated tests in place, this basically means that it's a lot easier for you to be up to date in terms of the versions that you're using, which is a great benefit both to the functional part. I mean, your customers will probably get features earlier. It will be, of course, the quality will be better, but also you will have less vulnerabilities. We sometimes see customers, and we see this in many of the vulnerabilities. So all kinds of users that basically have a specific version of the open source. The version is outdated, like maybe 2 or 3 years back, and there is a new vulnerability that is being disclosed. So of course, hackers are familiar with that, and if the vulnerability can be exploited, it will probably be exploited. So it's really important to have the versions up to date. The next point is nearly zero rework. So as we said, if I'm as a developer choosing the right component, not only in terms of the functional aspects, but also in terms of the secure ones, I will actually don't have to do any rework. So I will not have to work twice or even 3 times because let's say that after 6 months or after 5 months that I'm developing, the security person will come and tell me, okay, there is a security vulnerability, please change the version of the component, or please migrate to a different component, which means a lot of double code that I will actually have to write. Then, of course, we have the early identification of vulnerabilities in the code, and this is a very important point. As long as I will detect the vulnerabilities as early as I can actually remediate them a lot easier. So things that are very relevant are, for example, if as a developer, I can see the vulnerabilities in the IDE. So let's say I'm using IntelliJ or I'm using Eclipse, and I actually see the vulnerabilities in an extension as I code. I can already change the version in the very beginning of the process. Another good example is pointing out those vulnerabilities in the repository. So let's say I'm using GitHub or GitLab or Bitbucket, I can see the vulnerabilities in the issues in those repositories, and then I can actually say, okay, this specific repository has a vulnerability. Even before I actually build the version and deploy and release it, I can already see the different vulnerabilities. And then, of course, it enables a culture of constant iterative improvement. So very similar to the DevOps approach. The DevSecOps approach is all about continuous improvement and continuous deployment. So this is another very important point. So now let's take a look at the steps that we actually need to take in order to facilitate this in our organization, or like close the loop in a better way. So the first point is really to know the goal. And it's really important to be aligned on what is the goal. And if we look at the goal of DevSecOps as I see it, it's all about baking security into existing workflow. So all I have to do is basically define this as my goal, and then I know that the next step would be to look into the processes, to look into the different processes today in my organization. And by the way, every organization is different. Maybe you're fully into DevOps and you're using CI/CD and you have a continuous deployment and you have builds every 2 hours, or maybe you're not there yet. So it's really important to identify your own processes and see how you can fit and where you can fit the security aspects in the existing processes. And then the next point is, of course, identifying the processes. So this is a very basic one, but let's say that almost every organization will have at least these 4 processes. So the first one is the development, where the developer has actually developed the code. And by development, I mean there are 2 main phases. So the first phase with open source is usually to find the right open source component. So when a new developer actually gets a task, let's say it's a development task and you have to parse a JSON object. So of course, the developer is not going to write the parsing by themselves. They're probably going to use an open source component or library to do it. But there is more than one open source component that parses JSON. So they have to choose between a list of, I don't know, like 5 to maybe 30 different libraries. So the idea is to choose not only based on what's the easiest to implement or what does the functionality in the best way, but also look at the how much this repository is maintained, how many forks, how many downloads does it have. This will usually tell you about how easy is it for them to fix vulnerabilities. And the next point, of course, is whether they have existing disclosed vulnerabilities for one of the latest versions. And then probably you wouldn't want to choose that version with the vulnerability. So either you would choose a different component or you will use the latest version. Then, of course, we have the actual development, the actual person who writes the code. So this is the first step. The second step is the build. So it's both, packing it, testing it, if you're using Jenkins or Travis CI or Circle CI. So the idea is that you build your software, you test it probably in some automated tests. And then the next point, if you're using Docker or containers, is to put your image in a container registry. So if you're using one of the cloud providers registry, so this is that point, and then the actual deployment. So let's take a look at how and where you can, on which of these processes you actually have in your own organization. Maybe you're not using Docker and you go straight from the build to the deploy part. Maybe you have another test part in the middle. So this step is all about identifying your processes. And then if we go to the next step, it's actually about determining where we want to automate. So maybe we want to automate the building part. So as part of building my version in Jenkins, I also want to add some automated scanning for security vulnerabilities. This would mean that in every build that I have, in every time that there is a build, like let's say a nightly build, I also add the security aspect. I scan the code, and if there is a high severity security vulnerability, I can automatically fail the build. So this is just one example of how automation can actually help us with security. The next part is maybe I want to automate the issue detection in a better way. So I will try and focus on that one. It's really important to start with something. So probably the easiest is to start as left as you can around coding and building, and then move on to the testing and remediating. So automating the remediation, for example, it's a more challenging task, of course. Then if we look at all the steps, so it's basically detect, prioritize, remediate, and then repeat. So we see the detection as the very basic step. Of course, you have to know which vulnerabilities you have if you want to do something with them. The next point would be to prioritize in a smart way. And as we mentioned, prioritization is not done in the same way in each and every one of the companies. And usually when we speak about prioritization, we speak about the business aspect. So you can have a critical vulnerability, but if it doesn't impact your business, probably it's in a less priority to solve. And then the top part is after you prioritize and you chose which are the vulnerabilities that you want to focus on, the next step would be to actually remediate them, actually upgrade to the latest version or to the next version that fixes the vulnerability. Now let's speak about vulnerabilities prioritization, as this is a very important aspect and also a big challenge for many of our users. So what WhiteSource actually saw in some researches that we did is that there is a very big gap between effective and ineffective vulnerabilities in a component. And by effective, I actually mean that the proprietary code is making calls to the vulnerable functionality. So think about your proprietary code. You're probably using, like, let's say 10 different open source components. And in each and every one of these components or open source library, there are many lines of code. You're not using all the vulnerable methods. You're not using even probably 10% of the methods of the entire open source code. So an ineffective vulnerability would be if the proprietary code is not making any calls to the vulnerable functionality. So by this new approach, what we basically mean is that there can be a critical or high vulnerability that is not really effective and does not affect your code. And by some of the researches that we did, and we actually implemented this technology, of course, with many of our customers, we saw that around 80% of the vulnerabilities are in fact ineffective. So think about all the time you could save if you would just prioritize based on effectiveness, other than based on the severity, for example. So this is a very important point. The next part is the vulnerabilities remediation. So of course, that as we discussed, one of the best approaches to vulnerabilities remediation is to keep your components up to date. By doing this, you actually avoid being exposed to known vulnerabilities because, as we said, known vulnerabilities already have a fix in a later version of the same component. So what we can do as the next step is to actually automate the remediation workflow. And this can be done either by all kinds of policies that are triggered. So let's say when there is a new vulnerability, I want to automatically open a pull request to upgrade to the latest version or to the latest non-vulnerable version, for example. You can either have you can also have a policy or such rule based on the vulnerability severity. So only if the vulnerability is high, I want to actually open a pull request to remediate it automatically, or based on the CVSS score. Or you can go in the very sort of other way and say, whenever there is a new version for the open source, I want to automatically upgrade and remediate any potential vulnerabilities. Now, of course, automating the remediation workflows requires automated tests in place. So of course, if you don't have any automated tests in place, you have to first have your tests in place and then have this done. So it's another item to focus on. And then if we focus on remediation, so we spoke about effectiveness, which is the second point here, as a matter of prioritization. But we can also think about other aspects of prioritization. So we spoke about business priority. Exploitability is another one. So whether or not there is an actual code, an actual malicious code that actually exploits this specific vulnerability. If not, it's probably very hard for a hacker to exploit the vulnerability. So this is another something to think about. Of course, the severity and the availability of fixes are still here. These are things that we saw a lot of our users actually depending on the severity or prioritizing based on the severity. They're still here, but they're definitely not the first thing to look at when you prioritize vulnerabilities. And of course, not in some automated way. So the next point is sort of seeing the next level in terms of prioritization and remediation is actionable information. So always when we look at prioritization, we look at the minimum actions that we need to make with the maximum impact. So there's no need to actually have all kinds of different actions that will not give us impact. And the idea is to have the minimal number of actions. Let's say upgrade, don't upgrade all the versions, only upgrade part of the version that have the maximum impact. We also look at smart remediation by updating to the earliest non-vulnerable version. So we spoke about automated remediation and upgrading the components automatically. And the smart thing to do, of course, is to upgrade to an early version that doesn't have the vulnerability. This way, you have less chance of breaking backward compatibility or having non-stable code. So just to conclude this part, we see detection, prioritization, and then remediation as really like the next level of how we prioritize and how we handle vulnerabilities. So by doing all of these three things and automating them, we actually close the loop very easily. So the loop that we had before, right? From the moment that the security team or the security person detects the vulnerability or sends an email to the developer until the point where it's remediated, either in production or even in development, is a very long cycle. And by automating everything, we actually make it a lot shorter. So with that, it's time for some Q&A. So if you have any questions, please feel free to write them and we will answer all of them, hopefully, because we still have time.
Great, great. Yes, if you have a question for Shiri, please go ahead and use your GoToWebinar control panel. We've gotten a couple in so far, so why don't we go ahead and just dive right on in. Here's the first one. We spoke a lot about you spoke a lot about DevSecOps and the developer's role. How do you see the security team's role in this approach?
So this is a very important question because in DevSecOps, we're very focused on the developers. So what's the developer's role and how do they deal with security? But it's really important to mention that the security work is still there. So for example, doing this prioritization analysis that we discussed, like finding out which vulnerabilities can be exploited and which not. Or for example, the business priority or the actual priority of the vulnerability. So let's say that I have a vulnerability that can be very easily eliminated by just having a firewall in the organization. It's the security team's job to say, okay, we have this critical vulnerability, but there is no need to actually solve it because we have a firewall. And this vulnerability is not even relevant when you have a firewall in the organization. So it's still their role to sort of guard everything and look into each and every one of the vulnerabilities if needed. Another important note is that they need to set the policy of the organization. So things like we only handle medium and high vulnerabilities, or we handle based on business prioritization. They are the ones who actually need to set the tone and the processes for this entire DevSecOps idea. So their role, the security team's role in this new DevSecOps world is very, very important.
Excellent, excellent. Okay, next question. Let's see. I'm working in an enterprise company. Are there any specific challenges that you see for larger companies in adopting DevSecOps?
So yes, definitely. It's definitely easier to adopt DevSecOps when you're five developers, one security person, and one DevOps person, for sure. In enterprise companies, usually most of the processes are distributed between different teams. So in the process detection, like detecting the processes and understanding what are the processes that you need to automate, probably in a larger organization, you would need to do it separately for each and every one of the departments or for each and every one of the teams, which makes this process a lot more challenging because there is no one generic policy that you can implement. So we see this across different organizations that we work with. For example, some of the organization is already all the way into DevOps and have CI/CD in place and have automated tests and they're using Jenkins, and maybe the other part of the organization is not even there yet. So in a larger organization, it's really about identifying which teams in the organizations are the ones that need to adopt DevSecOps first. And for the ones who are less mature in the DevOps world, definitely we need to understand that and maybe find the right processes for them of how to implement this.
Excellent. Okay, great. Plenty of time, guys. If you have a question for Shiri, please use your GoToWebinar control panel. Our next question is, let's see, what's the best way to remediate vulnerabilities? Are there any specific tools for that?
So, as we said, the best way to eliminate vulnerabilities are to not to have them in the first place. And the method for that would be always have the latest version of the open source in place. If you already have a vulnerability, of course, you need to remediate it by upgrading your open source version. But by having your software up to date all the time, this already eliminates a very large part of the vulnerabilities. And in terms of tools, so one of the tools that I would recommend is Renovate. It's an open source tool, and you can actually go and use it and also contribute code. And this tool actually allows you to, it automatically opens pull requests for newer version of the open source, and you can sort of set all kinds of policies. So for example, you can say, I only want to upgrade minor versions automatically. And if there is a major version, so I don't want to upgrade that automatically. So I think it's a very good tool to start with if you're only doing your first step in actually remediating the vulnerabilities. Yeah.
Okay, great. Okay, next question. How can I improve my vulnerability prioritization? That's a good one.
Yeah, so we spoke about multiple ways to actually improve that. I think that the best way would be to look at all the aspects that we just discussed. So the first one would be the business priority. Let's say you may want to first prioritize and handle things that are in your core business, things that have access to sensitive customer data. So probably that code is the one that you will have to look at first, and then maybe later on look at other more, side components. Then of course we want to look at the effectiveness of the vulnerability, whether your proprietary code is actually calling the vulnerabilities. For that, you actually need dedicated tools. And then, of course, we can look at exploitability of the vulnerability, and we can look at the severity and all the other aspects that are there. But I would say that the most important thing is first look at the effectiveness and at the exploitability. That would be the first points.
Okay. All right. Great. Okay, go. We got some really good questions in here. Okay, here's a question about apps that don't see a lot of development for a while. Sometimes we have apps that receive active development and then they are left alone for a while. So how do you rescan those when you don't have pipeline builds?
So that's a very good question. So first of all, you can have scanning without any pipeline build. So let's say one of the things that we do is we have a Kubernetes cluster. This one is already in production. There is no active development happening right now. But what we do is we have a cron job that actually goes on a nightly basis, but you can also have it like every other week. And what it does is it actually triggers a scan for the entire cluster. So even if you're not building the software right now, even if you're not adding code, which is probably a very important note, you can have vulnerabilities. New vulnerabilities are being detected every day, right? So new open source vulnerabilities are being published even in your existing pieces of code. So even if you're not actively developing something, it's really important to have this continuous monitoring or continuous scanning for vulnerabilities. Yeah.
All right, great. Our next question here, how have you handled the relationship between security and developers if these integrating tooling systems ever did or could cause application issues, such as overhead crashes or just overall additional maintenance outside the normal build process of their core applications? So how do you handle that extra work issue, basically?
Yeah, so what we usually see is that handling vulnerabilities is anyway something that you will have to do on a continuous basis, and it's better to have your software and your processes set up once. So let's say integrating systems that basically cause application issue, or like let's say that you have some software that scans your code, and this causes the build to break. Of course, this causes a lot of problems and a lot of issues and a lot of overhead. But it's probably better for one build to fail or to break than to detect a vulnerability in production and have customers knowing about it or even being exploited by it and have like sensitive information stolen from the organization. So what we usually see is that this overhead actually eliminates a lot of noise from the production side. So what I basically say is it's better to do this work and have these tools on the left side of the pipeline than regret later after you have a vulnerability in production. I hope that answers the question.
All right, great. We do have a couple more minutes here, so if you have a question, please go ahead and use your GoToWebinar control panel and submit it. Okay, our next question. With Kubernetes and public cloud hosting of this, can firewalls that use IP ports keep up with the rate of change?
I'm not sure what this question means, but I would say that for Kubernetes and public cloud, some of the firewalls can definitely keep up with vulnerabilities. It also depends which vulnerability we're talking about, right? Because vulnerabilities can be like SQL injection, and they can be stealing your sensitive data, and they can be getting access when you actually don't want hackers to have access of your cloud host or your Kubernetes cluster. So I don't really know what this question means. Maybe you can clarify it. But yeah, definitely we have a lot of issues with Kubernetes public cloud, but yeah.
Okay. All right, great. Yeah. So Michael, if you want to go ahead and elaborate, just use the control panel and just put it right in the questions tab. We'll try to get back to it. Our next question: mastering these tools is, well, let's see. Hold on. Oh, sorry. If my organization is using Git, Jenkins, Kubernetes, etc., is mastering these tools enough, or do I really need to concentrate on OWASP or some kind of external vulnerability scanners?
So the answer is yes, you definitely need to consider OWASP or vulnerability scanner. So having managed software is, it helps a lot. I mean, if we're speaking about Kubernetes and you're using the EKS cluster by Amazon or GKE by Google, for example. So having that Kubernetes version managed it does eliminate some of the vulnerabilities, but still you have your own open source that you're using, right? So Git or Jenkins does not solve that. It's great that you're using these CI/CD tools and that you're probably doing continuous deployment, but you still need to scan your software using a security scanner or other tool. Yeah.
Okay. All right. Great. So many questions are coming in. This is awesome. Okay, our next question. Could you tell us some open source tools that you use to perform SAST DAST or SAST or DAST DAST scans?
Yeah, so SAST and DAST are both regarding proprietary code. SAST is static analysis and DAST is dynamic analysis. This is not really the focus. So this webinar was talking more about the open source part of the vulnerabilities. So our software is usually built of like the open source code, which by the way is most of your code. It's like probably 80 to 90% of your existing code is open source, and then 10 to 20% would be the proprietary code. So SAST and DAST are more about proprietary codes, and I don't have any specific tool that I'm using to protect those. No.
Okay, all right, great. Okay, next question. How do you think about actually measuring ROI for DevSecOps? Have you seen organizations track average release time, number of vulnerabilities in a release, etc.?
Yes, definitely. So I think that one of the most important things when implementing DevSecOps is have the right metrics in place. So things like the MTTR, like mean time to remediation of a vulnerability. How frequently do I close vulnerability or like security issues? How many security issues did I have when I first started using the tool or the DevSecOps approach versus how many do I have now, and really track that on a weekly basis. So I know that some of these graphs can be calculated, of course, manually. I know that we in WhiteSource offer some great tools to calculate these average and mean time to remediation, and the new open source that are being detected, the new open source vulnerabilities that are being detected. So you can definitely use those.
Okay, excellent. Okay, I think we have time for a couple more questions here. Where do you find more vulnerabilities in cloud DevOps? In setup or in cloud DevOps setup or on-premises DevOps setups in a private cloud data center?
The vulnerabilities are really about which open source components you're using and how frequently you actually update them. So it's not so much about whether you're using cloud or you're using on-premises. Probably if you're using cloud, maybe you have more frequent deployment, so maybe more easier to release software, therefore you will have less vulnerabilities. But I don't think that there is a major distinguish between like cloud versus open source versus on-premises in terms of vulnerabilities specifically.
Okay, great. Okay, so Michael got back with the question that he that you had asked for some clarification on. It says Kubernetes are constantly, often weekly, redeployed. As such, the IP and port they use for ingress or egress will change.
Yeah, but still, so this is a great point. Actually, redeployment each, let's say, weekly or even daily, depends on your software, helps a lot if you upgrade the version. It's true that also the IP and port would change, but if a hacker wants to exploit the cluster, probably they will find a way to do it. So it's not only about the IP and port. So I definitely think it's still important to have all the processes that we discussed about in place.
All right. Okay, great. Our next question here, if maturity is achieved in the left, what is the point of RASP in production, or is it simply another layer of protection?
Maturity achieved in the left.
The point of RASP,
so, yeah. Okay. So I'm not sure what you mean by RASP, but yeah, maybe they clarify.
We can come back to that one then if Mitch, if you want to send out a clarification on that. Runtime application security protection. Sorry. Thanks, Mitch.
Oh, so runtime application security is really important. So I would say it's another layer of protection. Having said that, of course, that we cannot remediate each and every one of the vulnerabilities. If we spoke about like hundreds or thousands of vulnerabilities in an average application, probably even if we use the right tools, we will not remediate all of them. So still, runtime application self-protection as a security technology is sort of another layer of protection, but maybe sometimes it will be your only layer of protection. So detecting and like blocking computer attacks by taking advantage of the information inside the running software or as part of running your application is very important.
Okay. All right, great. I think we have time for one more question, then we're going to go ahead and close it out here. Let's see. Are there any tools that rank or score open source components in a repository so you know which is most secure?
Yeah, so there are many tools that do this. Whitehorse actually has a great tool, which is a Chrome extension. So what we usually give our customers is a way to know for a specific, let's say you're in a GitHub repository and you want to know whether this specific repository has any security vulnerabilities, or even if you're working, like let's say in Maven Central or Savannah or some other place, and you want to know whether this component is actually secure, so you can just click on the Chrome extension, which will basically tell you how many vulnerabilities, will give you sort of a score or a rank for the vulnerabilities in that, for the security in general in that component, and also for the licensing aspect.
All right, great. Okay, I think we can squeeze in one last question and then we'll definitely close it out. Are there any organizations that provide certification for DevSecOps?
I'm sure there are.
But maybe that's
this is not really and this is not really what we at Whitehorse focus on. So we focus more on the open source management, which includes like the security, the licensing aspects, and the software composition analysis in general. But yeah.
Okay, all right, great. Great. Well, with that, we will go ahead and close out the question and answer period. Lots of great questions, guys. Thank you so much for sending over those questions. If for some reason we didn't get to your question, I apologize. But please know that Shiri will be getting a copy of all of the questions that came through. So either she or somebody from her organization, I'm sure, will be more than happy to follow up with you to get your question answered. Let's see. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. We are going to be sending out an email after today's event that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always look for it there. Just go to devops.com/webinars, look in the on demand section, and should be right there waiting for you. Let's see. Oh, also before we go, I promised you at the top of the hour that we would be doing a drawing for 3 $50 Amazon gift cards. So we're going to go ahead and do that now before we shut things down. Our lucky winners today are Mitch C. Congratulations, Mitch. Kim P. Congratulations, Kim. And Brendan B. Congratulations, Brendan. We will follow up with you guys offline by email to deliver your Amazon gift cards. So happy spending. Shiri, thanks so much for giving such a great presentation and for joining us today. Really appreciate it, as always. Great. I also want to thank the audience, I should say, for attending today's webinar. And for now, this is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.